My name is Kayla Yeargin. I teach at Troup High School and Troup County Schools. I teach Accelerated Algebra 1 and Algebra 1. Today's lesson will be in Accelerated Algebra over quadratics. Quadratics are 60% of their end-of-course test. Students will begin by making meaning out of characteristics and formulas used with quadratics. They will then use a real-life scenario of tossing a ball to their partner to identify different characteristics and how to graph a quadratic. All right, guys, we have 9 days until our EOC. What is a major part of the EOC? Quadratics. 60% of your test is going to come straight out of the quadratics unit. Today, what we're going to focus on are two main parts, characteristics and using those functions. In your buckets on your table, you see some white pieces of paper. We are going to make meaning out of quadratics. In your bucket, you will also see a note card that either says characteristics or equations. So each of you have a piece of paper, and there is a definition of what you're going to do in this bucket. What you need to do is jot down, you have 30 seconds, as much that you can remember about quadratics and either characteristics of quadratics or the equations of quadratics as you can. Okay? As much as you want, however you want, all over your paper. Are you ready? Go. If you have the characteristics, write down as many of the characteristics as you know. If you have equations, put down any type of equation for a quadratic that you know. It doesn't have to be in a straight line. It can be anywhere on your paper, however you want it to be. 10 more seconds. All right, pencils down. That was a short amount of time, right, for you to pour out all that you know about a quadratic onto a piece of paper. If you have characteristics, raise your hand if you wrote down vertex. Okay? Raise your hand if you wrote down axis of symmetry. Very good. Raise your hand if you wrote down the y-intercept, the x-intercepts, the roots, the solutions. What about intervals of increase? Intervals of decrease. Very good. In behavior, rate of change. Now, if you have the equations, if you wrote down quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, I did. Yeah? What about the vertex formula? Oh, I did that. All right. Anything else that we could put down? What is the equation for the y-intercept?
Mx plus b.
All right, but is that for a quadratic? You're right. That is for a y-intercept. What equation is that for, though?
Linear.
For a linear. Very good. And if we're looking for a y-intercept of a quadratic, we're looking for the c value, right?
Ax.
So see if you wrote down anything that looks like this. My characteristics are in purple. My equations are in blue. Okay.
Would you like us to write down?
Yes, take a few seconds to write down anything you don't have. And let's talk about how some of these things can connect. What does the quadratic formula?
The quadratic formula tells us the zeros, roots, solutions, or x-intercepts.
Very good. What does this formula right here tell me?
It shows you the vertex.
The vertex, very good. The difference is h and k tells me the direct vertex, right? Where in the other equation, negative b over 2a, I've got to find the y value. It gives me the x value of the vertex, but not the y. We just talked about 0c, right? Landon, what was 0, c?
It tells me the y-intercept.
The y-intercept, very good. So hopefully you see some connections. Take 30 seconds to connect different things on your paper, whether they're equations, whether they're characteristics, to make some good connections. Draw lines. Yeah, put them together. Draw lines. Connect them somehow, any way you want to. You can connect a characteristic to an equation. You can connect different characteristics, whether they're opposites or whether they tell us things that are similar. Very good. What do these things tell me as well? If it's a min or a max, then it's also the All right, let's take a second and see if your connections look anything like mine. Okay? Why did I connect concavity to maximum and minimum?
Because it's the way it goes.
It's my shape, right? John Will, help me out.
Yeah, like all those come together because it has to do with the shape of the loop.
The shape of the loop. What do we call the loop? Hayes, do you remember the name of the loop? The parabola, okay? So if I'm concave up, I make a minimum, right? The happy face U. If I'm concave down, then it's creating a maximum. What minimum or maximum also is connected to vertex? Tell me the definition, Ananda, of a vertex.
The place where the loop.
The loop, what do we call the loop, though? Use a math term. The parabola, yes. The zeros? Does it have to be on the y-axis, though?
No, well, it hits the line.
It's going to hit a line. What does that line tell us? What line does it hit? You're right. You want to phone a friend? The axis of symmetry. Very good. And that axis of symmetry in my parabola is where I change directions, right? If we're on the roller coaster and we're going up the hill, tink, 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 we hit that vertex, that axis of symmetry, what's going to happen after we go down? Or when we hit that point? You're going to go down. You're going to change directions, right? If you're in a swing and you've come back and now you're coming, you hit the axis of symmetry or the vertex, and then what's happening for the rest of your swing ride? You're going up, okay? So what I want you to do is we're going to do something to try and mimic this in real life, all right? So in your buckets, you have a couple of rulers, you have a ball, you have the stylus pen for the computer. In the computer on Google Classroom, you have a document. Please download that as a Word doc, okay? You're also going to need the stopwatch on your cell phone. You're going to have 4 positions. You're either going to be the thrower, you're going to be the catcher, the first timer, or the second timer. Don't worry, we're going to do this 4 times, so guess what? You get to do them all, right? So if you're the thrower, your job is really simple. You're going to throw the ball to the catcher, right? But you also need to remember where the vertex is because it is also your job to measure the height of the vertex. The catcher, your job is to catch the ball. And then you also need to help remember the height of the vertex because you're going to help measure that. Timer 1, you got 2 jobs. Before we throw it, you need to measure the height of the ball above the table, and you're going to time the ball all the way from the time it's thrown to the time it's caught. And then timer 2, you have to really be careful and watch for the vertex because your job is to measure the ball from when it's thrown to where it hits the vertex, and then also measure the height of when it's caught. Okay? So
hit that lap button when
yes, you can hit the lap button. Very good. So just like we said, you're going to record your findings. In this Google Classroom, you see where you need to sketch each toss, and then you also have a place where you can write down your recordings, whether it is how long it takes to get there or the height. So we're about to throw the ball. We have the thrower and our first timer. The thrower's going to hold the ball wherever it is that you want to toss it from. You have one stipulation. The ball must make a parabola. I don't care what the concavity of the parabola is, but it has to make a parabola. That's it, okay? So after we measure the height, it should look like this. These are the different positions. We have the thrower here, the first timer, our catcher, and our timer. All you have to do is actually throw the ball. That's it, right? Now, my catcher, whenever you catch it, kind of stick because we need to measure that height as well, okay? So after we catch it, make sure you measure your height. The only thing that I'm going to tell you when you measure your height is be consistent. Be consistent in your units of measure because otherwise you're going to have to go back and convert, right? When we say the height of the vertex, make sure that we kind of point it out. You can estimate, right? It's not going to be perfect. We don't have photographic memories where we can say, oh, that's the exact point, but we're going to estimate it, and then we're going to measure the height. Then you'll see this on your screens, right? So sketch what the path of the ball looked like. Depending on how you throw it, is going to be what your sketch looks like. Not everyone should be the same. You can also write down and jot the things that you need. When you're finished making all 4 tosses, you're going to come in and fill this in. Okay? Who was doing what, right? You have the stylus pens, whoever your recorder is can write down the different things. You can rotate that as well. Graph it out. Let's talk about what the y-axis represents here. Who can tell me, raise your hand and tell me what the y-axis is going to be? Hayes. It's the height. Now, does it have to be in inches?
No, it can be in centimeters.
It can be in centimeters. That's up to your group. Okay? What about the x-axis? It's going to be the time that's going to help me record my distance. Very good. Why do I start at 0 here? Remember when I jumped off of this thing? And we talked about people jumping off cliffs and making a quadratic? And we have 2 answers when you use the quadratic formula. Why could you not use one of the answers? Because what now? It's through the cliff, meaning it's gone negative, right? Can time be negative?
No.
No. Unfortunately, we can't go back in time. What about our height? Can height be negative?
No.
No. Okay, so make sure when you're labeling your graphs, you understand that as well. Okay? Here's your mission. Go ahead, assign your roles, and let's get started. All right. You're the thrower, you're the catcher. All right? Go ahead. All right, if you're getting ready to throw, all right, what do we have to do first before you throw? You're right.
Measure how high you throw.
Measure how high you throw it, okay? So you're going to throw it from there, okay? So we need to record this. Yes.
So,
Okay?
I've opened it in Word. Now, do I have to do a screen sketch or?
You can write on this and hit your pen. See?
Oh.
If you hit pens, now you can use that to write on it.
Okay.
Okay?
It'd probably be a lot easier to write off.
Yes.
Do we measure this part or the up part?
Well, you tell me, what job do you have?
I'm the thrower.
All right, if you were the thrower, your job was to also measure, what did we call this up part? The vertex, okay?
So mine's like up here.
Okay, so just remember that, and we can use the rulers to do that in just a second.
That's about 7.5 inches.
7.5, jot that down.
Do this one. There's
Yeah.
a total of 7.
Total of 7.5? Did you use 2 rulers or 1? Very good. So are you going to say 1 foot and 7 inches, or you want to do everything in inches?
Let's say.
How many inches are in a foot?
Let's do every inches. Let's do 19.5 inches.
Okay, good. All right, so make sure you record the time. And was that full distance time, or was that to the vertex?
Mine was full.
Yours was full. Okay. There you go. Now, when you hit lap, what does that represent? The change. Very good. So that's where I hit the vertex. What characteristic is that going to be? It's going to help me determine increase and decrease, positive and negative, but also what wall does that create? That's it. Okay, so when you get ready to graph those and talk about those characteristics, that's what you'll make sure you use. Very good.
No, you gotta start from the bottom if you're gonna start.
Okay. All right, but hold on. If this is my x-axis, I like what you're doing. If this is my x-axis, though,
You can start at 0.
can you start below 0?
Yeah, you gotta start like perfect.
Okay, if your hand's above the table, I'm okay with that. Just make sure your hand's above the table. I have a question. Does every ball have to go up and hit a vertex and come down? No? Could we bounce?
Yes.
Does that create a parabola?
Yes.
Yes.
And then we measured it.
Isn't it one where you have to like time it where it goes up and then hits it, then you have to time it when it goes down?
Yes. So one person will time when it goes up. One person will time when it comes down.
Oh. So there's not a time where it just all of them.
Yeah.
So
One person has to do the whole thing.
I did that.
Okay. And so then your job will be to
And
just from when she lets it go to the vertex. So if you're going up, then fine. If you bounce it, then it's going to be the other way.
About 3.1. It started.
So when it starts going to the high point, then you like go. Okay.
that's
Make sure you kind of get it across the table a little bit. Yes. Touch your pen to the screen. And then hit Ink Tools. There you go. Now you can write on that. You think you're doing it wrong?
Okay, that's why my hand opened up. When I did this, my right finger pushed up.
That's not a good throw.
It went up to the left.
So at Matt's, it was about 14 inches max.
Yeah, it looked pretty. Not for that. It was
Okay.
Right here.
So when you sketch, does it have to be perfect?
No.
No.
So this is where.
So just show me the path of the ball that you're doing right now. Show me what the ball did.
That's like that.
Okay.
Or no, someone caught it about right there.
Okay.
So yeah.
And so,
Probably about right here.
Yeah.
so if he catches there, perfect. Now when you get ready to graph it for real, that's when you want to put your actual times in there. Does that make sense?
Okay, so that's just a sketch for right now.
Yes, that kind of lets you remember. You can do this at the beginning, like before you make your next toss, or you can go at the end.
Okay.
Okay.
So do you guys want to go ahead and do this part? Or-
fill it all out.
Yes, ma'am.
Do we have to take a screen?
Yeah, you need to sketch what happened.
And like label the sides.
Hold on. Do you have this downloaded? This way you can write and you don't have to save.
It started at 12 inches.
Okay.
That must be it.
Yeah. Okay. Touch your pen to the screen. There you go. Ink Tools. Now you have. There you go. You can pick a color, and now you can write directly on your screen. All right.
Oh. Or making it, okay.
You can't catch it like this.
I make a parabola.
Oh.
Okay.
Okay.
Is this our height? There we go. All right. So remember where you caught it. All right. Hold the ball there.
Yeah, around
There we go. Now we can measure this.
1'2".
Let's use the rulers
We're just measuring pens. We're doing it
14 inches.
and pens.
4.5 pens.
About 4, right?
Okay, so is it just 4 inches?
I feel like 4.5. Yeah.
The balls.
Okay, if it's at 4.5 though, how many rulers did you use?
It's 16 and a half.
Oh, I'm tripping.
So there you go. So you got to take the 12 inches from the first ruler. Very good.
So what was the time number? And then it was caught at 19 and a half inches.
Very
Are
good.
we supposed to do any more inches?
You got start, vertex. Now you need to make sure you put where it was caught, which is what I just told you was.
19 and a half.
Write down caught
Finish.
or finish. That's fine.
We didn't do the inches though for call, like where she called it at. What do you mean?
Yeah, we did.
Yes, you did.
It's 19 and a half.
She wrote it down.
Inches? Yeah. Okay, I thought you were saying 19 and a half.
Okay.
Like,
No. And then you've got your time that you'll write down as well. Now, what did this look like? Was it concave up or was it concave down?
Okay, down. It was.
All right, show me with your hands. Show me with your hands what happened with the ball. Okay, now if I do this, is that concave up?
no, down.
Concave down, right? Because everything that happened is below the ball, right? And so if it's concave down, your A value needs to be what kind? Positive or negative? Negative, right? Because if it's a positive, that makes us the positive parabola. Very good. So when you get ready to graph, that'll be there. Yes, sir.
It would never hit the x-axis though, right?
Very good. So are there any?
None. And just like how there actually would be a minimum, which would be that point right there.
Very good.
Okay.
Now that's real life. If this were a continuous,
Because it's a stop. It
Very
stops
good.
at those points.
very good. Everybody pause for 1 second. I know you still have some more work to finish, but Hayes just made us a good point. For every function of a quadratic is continuous, right? Is this graph going to be continuous?
No, ma'am.
No, because we have a starting point, we throw it, and it has an ending point, right? So for any continuous quadratic, do we have a maximum and a minimum? No, it can only do one because it's going to go forever, right? If it's concave down, it's going to continue forever and ever and ever to negative infinity. If it's concave up, it's going to continue all the way to infinity. So I either have a minimum or maximum. On your graphs, will I only have one?
No, you'll have to,
I'll have two. Why?
because it's a start and a finish.
There's a start and a finish. I throw it, it either hits a highest point and then I catch it and it's a lowest point, depending on if I throw it or catch it, what point, right? And then also if I bounce it, I'm going to have a lowest point. If I bounce, where's my lowest point? 0. It's got to hit the table, right? This thing's got to bounce on something. So if I'm looking for that lowest point, in this case, if I bounce, my x-intercept is going to be the point where it hits the table, that time where it hits the table. Keep that in mind. So for continuous functions, you're right, there's either one max or one min, but for our functions, there should be both. Okay? Make sure that you remember that as you are working through these.
Would that also change in behavior too?
That-
Because it wouldn't be going to infinity, it would be approaching, like as it approaches here, like it'd be the minimum and maximum, right?
Very
as
good.
X approaches 3.1, Y approaches 15.
Yes,
Okay.
because it does have that starting and ending point. Very good. If you've not made a concave up and a concave down, I suggest that you do at least one or of either, okay?
Let's say like, it's gonna press the button. That's what I'm doing.
Okay. So you're rotating each spot so you have one of each, right?
So, yeah.
Okay.
We should record it.
You could record it. That would help.
That's a great
If you want to do that,
How'd you come up?
you could record that. I'm okay with that. All right, Chris, I'm going to borrow your ball.
This one does better than the other.
Does it? Yes, ma'am.
For vertex, what do we graph? Do we graph the
Well, you tell me. What's the highest part?
27 inches?
All right, 27 inches. So that's what part of your vertex, the X or the Y? The Y. How do you know what the X is?
The time.
Very good. So what was the time that matched 27 inches? 0.42. So on your graph, what you're going to do is go out to 0.42 and then go up to 27, right?
Timer.
All right, I need 4 volunteers.
We'll do.
Ananda, Chris, Jawil, and Hayes. All right. You guys are going to help us. What you need to do on your piece of paper, everybody other than these 4, sketch what happens. Okay? So, Hayes, you are going to time us from start to finish.
Okay. You want me to lap it every time it hits a new point?
No, I want you to just go start to finish. Okay? Jawil, I want you to time us from when we go to our vertex. Okay? You're going to have to lap twice. You're going to do the first toss. Jawil, you and Hayes are doing the first toss. Ananda, you're doing my second toss. Okay? I'm going to toss the ball twice. Okay? So you were going to time start to finish of the second toss. Chris, you're doing toss to the vertex of the second toss. Okay? Do you have a timer? Okay. When I'll tell you what to do. Are you ready? Hadley, are you going to catch this for me?
Where are we at?
You're right here. You ready? Okay, so every person in the room needs to right now sketch this, what's happening. Are you ready? Okay, Hayes and Jawil, you ready? Yes, I'm on you.
I got vertex and then.
You got to the vertex, yep.
3, 2, 1, go.
Okay. Good? All right, now are you ready? So we're going to estimate, just make sure that you sketch that graph first. All right, now Hadley's going to toss it back to me, but you have one stipulation when you toss it back. It needs to bounce on the table to me, okay? Now, I got Chris and Ananda. Yeah, from that point. Chris and Ananda are going to time. Ananda, you're going start to finish. Chris, you're going to the vertex. Are you ready? Back up.
All right.
Count her down.
3, 2, 1, go.
All right. Very good. Now, on your paper, make sure you sketch toss 1 and toss 2. You're going to finish. Under my first toss, write what the A value of my quadratic would be. You can just put positive or negative. The first one is where I tossed it to Hadley. And under the second one, write what my A value would be. Positive or negative. Write the x-intercept of the first toss, where I tossed it in the air to Hadley. If you don't know if there is one, you can put I'm not sure. Make sure you put what you think the x-intercept of the second toss is. List these same characteristics for our 2 tosses on your paper. Now, we don't have the exact times yet, do we? So, Hayes, what was our time start to finish of the first toss? Everybody needs to write this down. Toss 1. 1.33 seconds. We can estimate that to 1.3 seconds. So start to finish, my first toss was 1.3 seconds. Jawil, where did I hit my y-intercept? Or my vertex, I'm sorry.
Vertex on the first toss, you hit it at
0.36 seconds. So make sure you write that down. All right, Ananda, what was the time start to finish of my second toss?
2 seconds.
2 seconds. So second toss, 2 seconds. Somebody want to tell me what these are?